Let's take a look at your MT3 LT5 seminar on proving segment relationships. First thing, we're going to do a proof that has nothing to do with segments as a warm-up. I just want you to put this proof in order. Go from the beginning to the end. You should start with your given and end with what you're trying to prove. On your state standards, I usually don't talk about these, but I do want you to notice this whole chapter. We're proving theorems about lines and angles. That's the reason we're doing this. And then we're going to prove theorems about line segments using the segment addition postulate. And we're going to prove theorems about segments and congruence. First off, I noticed my word processor auto-corrected. They changed launch to laugh. So go into your textbook and let's do that together. And we are going to take a look at launch this lesson here. And what's going on here? Why did my video go so fast? Now let's just go from the beginning. Okay, so what we have here is we have Cher, and she's measuring the window for curtains. So we notice first she measures 36 inches, and then she measures an additional 12 inches. So the width of the window is going to be those two added together, which is 48 inches. Because she wants two curtains, she's going to double that for 96 inches. What she used there is the ruler postulate. And what the ruler postulate allows us to state is I can call anything 0. And I can call anything 1. So what that does, that allows me to measure meters, centimeters, miles, feet, whatever I want. So I can use multiple units to measure a segment. And it also tells me that it could be all my numbers are going to be positive. I can't have a negative distance. We kind of did that in chapter 1. We also kind of alluded to the segment addition postulate in chapter 1. We just never named it. The segment addition postulate says that my segment is equal to the sum of its parts, provided everything's collinear. So the segment addition postulate says I can add 2 segments up, and as long as they're back to back, I'll get the third segment. I could do that with 4 or 5 or 6 segments. Provided they're all connected, I can just add them up. Let's apply that, what we just learned, to a proof. Notice I have 2 givens. I'm given CE is congruent to FE. I'm given that ED is congruent to EG. Put 2 tick marks on there. I suggest you do the same thing. So when I look at my proof, I know my first part is given. And then I'm changing my congruent sign to an equal sign so I could do some algebra. So I can always change a congruent sign to an equal sign. That's going to be our definition of congruence. In this case, congruent segments, we'll say. Can always change an equal sign or congruent sign to an equal sign and back and forth. Now we're going to do what we just learned today. That is CE plus ED, that equals CD. So that's our segment addition postulate. Now we're given that CE is the same as FE. So what happens here, instead of writing CE, I'm going to write FE. Instead of writing ED, I'm going to write EG. That's your substitution property. If I could spell it right. And then FE plus EG, well, that equals FG. So I'm back to my segment addition postulate. Forgot my word addition on step 4. Now notice my last two statements, they're the same. I got FE plus EG and FE plus EG. So instead of saying FE plus EG, I'm going to write CD. When you write CD instead of that, that's going to be substitution because we're replacing something with something else. And then finally, I'm changing my equal sign back to a congruent, so it's definition of congruent segments. So the new reason we learned here was your segment addition postulate. And that's usually what happens when I'm trying to prove two big things are congruent. I'll show their parts are congruent, and I'll use substitution to show that the whole things are congruent. Now, when we talk about properties of segments, that same thing that goes with numbers goes with segments. We have the reflexive property that says, hey, the segment is congruent to itself. We'll use that later on in chapter 5. We have the symmetric property, which we kind of did yesterday. That is, I can switch sides. If AB is congruent to CD, I can write CD as congruent to AB. And then we have the transitive property. Everything is congruent. The important thing about these, they're congruent properties. I don't have to change them to equal signs. I can always use congruent.